Hello all. Today we're going to take a look at what matrix multiplication is. So the first thing we're going to do is we're going to bring back that example we did yesterday where we had 9th, 10th, 11th, and 12th graders and then their orders. So if we wanted to figure out how much the 9th grade class was going to pay, how much the 10th grade class. So if we wanted to end up, and we could put this in like a matrix again. If we wanted 9th, that didn't turn out, 9, 10, 11, 12, with like a matrix with how much money they've spent, what would you do? Well, let's see. So for our 9th graders, we have all of this. We need to figure out their cost. So 50 pizzas times 2 plus 130 sandwiches times $1 plus 25 pastas times 3. So let's see, 100, 230. So they spent a total of $305. So then we go for 10th grade. 10th grade times the cost. So we do 150 times 2 plus 100 times 1 plus 26 times 3. So we have 300, 400, 478, if I did that right. Then we keep going for the next one. So we would have 122 times 2 plus 37 times 1 plus 150 times 3. And then that's the 11th grade and 12th grade. So this is the way matrix multiplication works. You multiply in a row by a column to get a certain element. So in order to use matrix multiplication, for example, if I was to have a matrix 2, 4, 5, 6, this is a 2 by 2 matrix. And then I was to have a 2, 3, 4, 5, 6, 7. This one is a 3 by 2 matrix. And if I was to have 2, 5, 8, 6, 7, 9, this is a 2 by 3 matrix. In order to multiply a matrix, if you were to place their order or their dimensions next to each other, so let me label these A, B, and C. If I was to put A to B together, this is a 2 by 2, and then B is a 3 by 2. If I was to put A and C together, A and C is a 2 by 2 by a 2 by 2 by 3. And if I was to put B, C together, 3 by 2, 2 by 3. In order to multiply matrices, the middle numbers, they have to match. And your resulting matrix, so these don't match, so this one's not possible. This one they match. Your resulting matrix is a 2 by 3 matrix. The middle one matches. Your resulting when you multiply is a 3 by 3. So now we're going to take a look at some of these. So for example, first of all, I'm going to list out the dimensions. So this one's a 2 by 2, a 2 by 2, 2 by 3, 1 by 3, a 3 by 1, and a 3 by 2. So let's see if these are possible. So A times B, this is a 2 by 2 times a 2 by 2. All right, so our resulting matrix is a 2 by 2. So when we multiply matrices, this first, it's going to be a 2 by 2 matrix. And I'm going to delete some of this. So we have row 1, column 1, row 2, column 2, row 2, column 2, row 2, column 2. Excuse me, this top one should be row 1. Okay, so, and I'm going to cross these out. We don't have quite enough room for those. So to get row 1, column 1, we do similar to what we did. So row 1, column 1. So that is going to be 2 times 6 plus 5 times 5. So 12 plus 25 is 37. So to get the next element, row 2, column 2, what we're going to do now is take row 2, excuse me, I messed up. I apologize here. This should be column 1. And right here, this is column 1. So I highlighted the second row in the first column. So we have 3 by 6 plus 14 times 5. And so let's see, 70, so that's 88. So I'm just gonna, so we have row 1, column 1, row 2, column 1. So now I could do row 1, column 2. So I'm going to go back here, row 1, column 2. So we have 2 times -5 plus 5 times 2. So again, that's 2 times -5, 5 times 2. So that gives us 0. And then we got row 2, column 2. So I'll erase this stuff. So row 2, column 2. So 3 times -5 plus 14 times 2. So 28 minus 15 is 13. So your resulting matrix would be 37, 88, 0, and 13. So let's take a look at another one. And I think I'm gonna I'll copy this and put it down below so we have some more space because that didn't work out very well. So B and C. Okay, so let's see. So this is a 2 by 2. This is a 2 by 3. So these numbers match. So our resulting matrix is a 2 by 3. And I'm actually going to put this up here. So a 2 by 3. So we have 1, 2, 3. We have those elements to fill. So again, this is row 1, column 1, row 2, column 2, row 1, column 2, row 1, column 3, row 2, column 2, row 2, column 3. So let's see, row 1, column 1, row 1, column 1. So 6 times 0 plus -5 times -5. So that first element is -25. So now we have row 2, column 1. I keep rewriting these, I'm sorry. So this one here should be column 1. And then go back here, row 2, column 1. So we start with 5 and 0. So 5 times 0 plus 2 times -5. So we have -10. Okay, so then we got row 1, column 2. Row 1, column 2. So we start with our first element. So 6 times -2. So I might just write -12 Negative 5 times 11, negative 55. So let's see if we add those together. We got negative 67. So now we have row 2, column 2. So row 2, column 2. So 5 times negative 2. So we got negative 10. 2 times 11 is 22. So this one gives us 12. So now let's see row 1, column 3. Row 1, column 3. So we start with that. So 6 times 3 is 18. Negative 5 times 4 is negative 20. So this would give us negative 20. And so our last one, row 2, column 3. So we gotta switch this one. Is now row 2, column 3. So our first elements, 5 times 3, 15. 2 times 4 is 8. So we end up with a total of 23 right there. So you can see these take some time, but you will be asked to do these by hand. This is something that shows up on the ACT. So we will be practicing doing these by hand. Now, let's say I said multiply these. All right, so if we list those dimensions, this is a 3 by 1, 3 by 2. These middle numbers aren't the same, so it's not possible. All right, and let's see if we can take a look at one last one here. All right, so if we were to multiply these, so this is a 1 by 3, a 3 by 1. So the middle number's the answer. So our outside dimension, the last one, it's just going to be a 1 by 1. So it just has a row 1, column 1. So if we look at that, row 1, column 1, there's only 1. So we got 1 times negative 4 is negative 4. 2 times 4 is 8. And then this last one, negative 3 times 1 is negative 3. Add those together, we have a total of 1. So our matrix, resulting matrix, is just the number 1.